Okay, welcome in. In this video, we're going to talk about applies, which are nice. I think they're relatively speedy kind of expression in R. They can be a little bit tricky, I think, for when you're starting out, but very useful for when you want to apply a function over data. And we've seen so far for loops or while loops are kind of a way to apply some sort of function over data, but these are more efficient and I think cleaner ways to do it. So as usual, we're going to be looking at the iris data, which is available in your base R instead of me loading some random data set from the internet or from my desktop. We just have this nice flower data. And I was playing with this before and I forgot to move a column that we're going to define. So bear with me. Let me just do that. Okay, I have my data here. And this is a column from another video. So I'm going to take that out as well. The way to take out columns in a data table is just to assign the value null to them. And then when you look at the data table, that column will be gone. So a nice little bonus tip. So here's a bunch of different columns and the species value. And let's say we want to look at this sepal length column. We want the value squared. So the simple way to do it would just be R is vectorized. So we could just type in the vector, square it, as 2, and we're going to get all the values squared. That's a nice way to do it. We're going to show you the way to do it with sapply, which is a little bit redundant, but it'll let us understand how to use sapply, and then from there we'll be able to do it more complicated. So the function is called sapply. I'm not sure why why there's S, why the S is in front. And there's probably a reason I could probably find out easily, but that's something you can Google. But sapply is when we want to apply something over a vector, and we're going to talk about some examples when what we're applying over is not a vector. So we want to apply over sepal length, and let's do petal length because I think petal length is like more intuitive. I don't know what a sepal is, so we want to apply over petal length. So that's our first argument. Our second argument, the main argument, is the function that we want to actually apply over the petal length. And in this case, we want to apply the square function over. We don't really have a good function to do that, so we're just going to define a function on the fly. This function takes the value x, my curly braces, and then what code I actually want to run. And we can all do this on one line because it's not that much. But we're basically saying what function do we want to apply? Some function x, it's unnamed here. And we're just going to take the square of x. And if I run this, you're going to see I get the same result from when I just squared it myself, 1.96, 1.96, 1.69, and when you did the sapply, 1.96, 1.96, 1.69. And so that's pretty cool. We're sapplying this function over this vector. And again, this is a little bit silly because it's much shorter and easier with this line. However, there might be some function that you want to apply that's not as simple to just apply to just do in one line vectorized like this. One example, which I think you may be able to do, simply, but it's a little bit more of a complicated function. So sapply might be easier. Is let's say you want to add a percentile column. You want, to convert these values into a percentile instead of like just 3.61. You want to see what percent of values is it 3.61 greater to. You could do that in one line, but we're going to do it in sapply. And what we're just going to do is we want to, I just want to make sure I don't mix up we want to return the mean of iris petal length that's less than or equal to x. Okay, so let's think about this for a second. When we take the mean of a bunch of numbers, right, we are going to get, basically, if I just type in like 5 is less than 7, that's going to give me true. And if I take the mean of that, that's going to be 1 because it's taking the mean of a Boolean vector, true or false. In this case, it's just true. So it's going to say it's true half the time. If I did mean of C true false, I would get 1/2 because it's true 1/2 the time. So taking the mean of this is going to give me a vector. Remember, we're sapplying over every length in this vector. For each length, for each x, we're going to look at all the petal lengths. We're going to see if each one is less than or equal to that length. It's going to give us a Boolean vector of true or false, and then we're going to see on average how many of those are true. So a little bit funky, but if we do that, we're going to get our nice result here, and I'm going to define that. I'm going to define that as iris percentile, And I'm just going to add this new column. And you can see, these are kind of like very a little bit ugly numbers. So I'm just going to add a nice little round. I'm going to round to 2 decimal places. So I don't have to have these gross numbers. And look at that. We have now our percentile column in Iris for the petal lengths. And it can be useful to check and make sure that what we did makes sense. So let's see. First, let's see what the maximum of the percentile is. 1, that's good. We have something in the 100th percentile. And now we want to, Iris, and where Iris percentile equals 1. We want to see what row we actually have percentile 1. Here's the row. Petal length of 6.9 is in the percentile 1. Let's make sure that a petal length of 6.9 is the max. It indeed is. So it checks out what we did works. The maximum petal length is 6.9. That's in 100th percentile. It doesn't prove that it worked, but that kind of gives us a little sanity check. So that's nice. That's a nice little function. It's pretty fast. You didn't really have to think too much because you could think about the elements one at a time, like one element X at a time, instead of, kind of working with the whole vector at a time. You just kind of, it's similar to looping, but it's just applying over the vector. Another cool and useful type of apply is just apply instead of sapply. And what apply does is it applies a function kind of over a data frame, a matrix, a data table. In this case, we want to, let's say we wanted to find the standard deviation or the variance of all the columns in Iris. We don't want to find it of the species column because clearly it's characters. It doesn't have a standard deviation. It doesn't make sense. It's not a numeric. So I'm going to just look at everything but the 1, 2, 3, 4, 5th column, the species column. So to do that, I just take Iris, all rows, not the 5th column, and ahead of that. And I get, kind of these values. And let's say I want to do the standard deviation of these values. It's not immediately clear unless you know some function that automatically does it. It's not immediately clear how you would kind of calculate this. So applied is very good at doing it. We pass in the function, and then we say, which way do we want to apply the function? Do we want to apply it by rows, which is we would put 1, or do we want to apply it by columns, where we would put 2? And in this case, we want to apply it by columns. We want to apply it over the sepal length column, over the sepal width column, over the petal width length column. And the easy way to remember this is you can always just type $apply and just read through the literature, but just remember rows are 1, columns are 2 on this row column. That's kind of the way I remember it. New dance move. And the function we want to apply is simple in this case. We don't even have to define a crazy function like we did up here. We just want to take the standard deviation. So we just type SD and we hit enter, and look at that. We get the standard deviation of each column. If I wanted to make this a little bit cleaner, I could do function X, and then let's say round SDX 1. So in this case, we're just going to round to 1 decimal place. And now I have my nice standard deviations. You can see that petal length has the largest standard deviation, petal width has, and sepal length has the second largest. And again, we can just check this to make sure that we're not getting bamboozled by taking the standard deviation of petal length, and we do get something like 1.8. If I change this number to 1, I will be doing it by rows. So what do you think the output is going to look like in this case? I'll give you a second. You can pause the video. So in this case, if I hit control, I'm going to get a standard deviation for every row in the table, which is basically a standard deviation for every flower observed, which can also be useful. You might want to do this by row in addition to column. The last thing, we're not going to really do it, but there's a couple of applies, but there's also lapply, which applies over lists. So sapply applies over a vector, apply applies over a matrix or data frame, lapply will apply over a list that you have. And it's the same format. You apply over the list, you define the function that you're going to do for each list. Again, think of applying as just, you can think of it as a for loop even, but it's applying some function over some object and spitting out the results in a fast and efficient way. So hopefully you enjoyed this video on applies, and we will see you next time.